IAM. When you develop applications, you might require people or applications to authenticate. For example, suppose that you're developing a mobile photo app. Users take pictures with their mobile device and then use the app to upload the pictures to AWS. As the developer, you must use your AWS credentials to authenticate to the AWS account to confirm that you are who you say you are. Likewise, an app user must sign in to the photo app, which requires that they authenticate with your app. Additionally, when the user takes a picture and uploads it, the photo app must authenticate to the AWS account. The app must authenticate before the account allows access to a service, such as Amazon S3, where the photos will be stored. Finally, when the photo is uploaded to an S3 bucket, a back-end job is started to add an entry to an Amazon RDS database. This job requires database authentication. You must authenticate whether you access AWS services from the AWS Management Console, AWS Command Line Interface, also known as the CLI, or AWS Software Development Kits, also known as SDKs. To authenticate, you must provide AWS credentials. Two primary types of credentials are used for authentication: a username and password, or an AWS access key. The credential type depends on how you access AWS. To authenticate from the console, you must sign in with your username and password. To authenticate programmatically through the AWS CLI, SDKs, or APIs, you must provide an AWS access key. An AWS access key is the combination of an access key ID and a secret access key. You might also be required to provide additional security information. For example, AWS recommends that you use MFA to increase the security of your account. Multi-factor authentication, or MFA, is a best practice that adds an extra layer of protection on top of your username and password. MFA requires 2 or more factors to achieve authentication. Factors include something you know, such as a password, something you have, such as a cryptographic token, or something you are, such as your fingerprint. When MFA is enabled, after a user signs into the console with their username and password, something they know, they're prompted for an authentication response from their AWS MFA device, something they have. You can add MFA restrictions to your IAM policies. You might need access to APIs and resources that are protected in this way. If so, you can request temporary security credentials and pass optional MFA parameters in through AWS Security Token Service, also known as AWS STS API requests. MFA-validated temporary security credentials can be used to call MFA-protected APIs and resources. AWS Security Token Service, or AWS STS, is the service that issues temporary security credentials. This service will be covered in more detail later in this course. With an IAM role, you define a set of permissions to access the resources that a user or service needs. However, the permissions are not attached to an IAM user or group. Instead, the permissions are attached to a role, and the user or service assumes the role. When a user assumes a role, the user's prior permissions are temporarily forgotten. Then, AWS returns temporary security credentials that the user or application can use to make programmatic requests to AWS. When using IAM roles, you don't need to grant long-term security credentials to each entity that requires access to a resource. For a service such as Amazon EC2, applications or AWS services can programmatically assume a role at runtime. The principal that assumes the role might be an IAM user, group, or role from another AWS account, including accounts that you do not own. By creating a role for external account access, you don't need to manage usernames and passwords for third parties. If you no longer want someone or some system to have access, you can modify or delete the role. Thus, You don't need to create and manage accounts for people outside your organization. At times, you might need to provide trusted users with temporary security credentials to your AWS resources. In this case, it's a best practice to create an IAM role with temporary credentials instead of creating an IAM user. Consider the following examples of when you might need to use temporary security credentials. For example, an IAM user in one AWS account might need temporary access to resources in another AWS account. Another example, user identities that were authenticated by a system outside AWS might need to perform AWS tasks and access your AWS resources. Examples of such external systems might be an enterprise identity provider or web identity provider. This process is referred to as identity federation. Another scenario is a mobile app that needs access to your AWS resources. You don't want to store AWS credentials with the application, where they can be difficult to rotate and where users can potentially extract them. And a final example, you can provide temporary security credentials to applications that run on EC2 instances and other AWS compute services. In this way, you don't need to store long-term credentials locally. Several ways are available to support calling AWS services from an environment in AWS Cloud 9. First, you could use AWS Managed Temporary Credentials. For an AWS Cloud 9 development environment on Amazon EC2, AWS Cloud 9 makes temporary AWS access credentials available to you in the environment by default. These credentials are called AWS Managed Temporary Credentials. AWS Managed Temporary Credentials manage AWS access credentials in an Amazon EC2 environment on your behalf, and they also follow AWS security best practices. Second, you could attach an IAM instance profile to the EC2 instance. Similar to AWS Managed Temporary Credentials, an instance profile manages AWS access credentials on your behalf. However, you must create, manage, and attach the instance profile to the EC2 instance yourself. For applications that run on EC2 instances, we recommend that you create an IAM role and attach it to your EC2 instance. The IAM role allows your applications to securely make API requests from your EC2 instances. Thus, you won't need to manage the security credentials that the applications use. The third option is to store your permanent credentials within the AWS Cloud 9 environment. This approach is less secure than using temporary AWS credentials. However, it is a supported approach for an AWS Cloud 9 Secure Shell, or SSH, development environment. After the AWS CLI is installed, you can use it to interact with one or more AWS accounts. To set your AWS credentials so that the AWS CLI client can use them, run the configure command. The AWS CLI stores the credentials you set in your home directory in a local file named credentials, which is in a folder named .aws. The default location for your credentials file is in the ~.aws/credentials on Linux, macOS, or Unix. On Microsoft Windows, the default location is c \users \username \.aws/credentials. Using an AWS credentials file offers a few benefits. First, your project's credentials are stored outside of your projects, so it's unlikely you'll accidentally commit them into version control. Second, you can define and name multiple sets of credentials called profiles in one place. In this example credentials file, you see AWS access key credentials for two profiles, one for default and one for prod or production. Third, you can reuse the same credentials between projects. And finally, you can reference your credentials when you're using other supported AWS SDKs and tools. When you use the AWS CLI, you can also specify which profile to use. You can use the AWS CLI to switch between profiles and access keys. You can reference profiles from an SDK configuration file or by using the profile option when instantiating a client. Here are the key takeaways for this section of the module. IAM roles with temporary credentials are preferred for applications that run on Amazon EC2 and for mobile apps. And avoid storing AWS credentials in code or in publicly accessible places. Use credential files instead. That's it for this video. Thanks for watching, and see you in the next.
Welcome! In this video, I'll show you how to configure cross-account access so that resources in one AWS account can be accessed from another AWS account. This diagram shows what I'll accomplish in this demonstration. First, I will create a resource that I want the other account to be able to access. In this example, the resource is an Amazon Simple Storage Service, or Amazon S3, bucket with an object in it. Next, I'll define an AWS Identity and Access Management, or IAM policy, and an IAM role to attach the policy to. Then, in the other account, I'll define an inline IAM policy that allows the user to assume the role I defined in the first account. This will allow the user to access the S3 bucket. Okay, let's get started. In this browser, I'm logged in to the production account. Notice that the upper right corner of the AWS Management Console window shows who I'm logged in as. It also shows the account number of the AWS account that I'm authenticated to. So I'll first create a resource. In this case, an S3 bucket. Notice I'm keeping public access blocked. I will accept all the default settings and I'll create the bucket. Now, I'll add an object to the bucket. I'll just add a simple image file. I'm going to copy the bucket name because I'll need it in a moment. And I'm going to create a second bucket as well. I want two buckets in the account so that later when I grant access to one bucket, I can show that I'm not granting access to all the buckets in this account. Next, I'll load the IAM console and create an IAM policy. The policy should grant access to all actions in Amazon S3. However, under Resources, I want to indicate a specific bucket. I choose Add ARN, and now I'll paste in the bucket name that I just copied a moment ago. This will grant access to the bucket, but I also want to allow access to the objects in the bucket. To do that, I'll choose Add ARN, and for the same bucket, I'll choose Any for object name. Based on the input I provided, the wizard built a JSON-formatted policy document. The policy has two statements. In the first statement, the SID, which stands for Statement ID, is a name-value pair that has a value of Visual Editor 0. This is an optional identifier. If you use one, it must be unique within the policy. Next, the effect is set to allow. Then the policy has a list of specific S3 actions that this policy will allow. The second statement allows all S3 actions. However, it only allows them on two specific resources. The first resource is the bucket that I just created, and the second resource allows actions on any object in that bucket. I don't need to add any tags, but I do need to give this policy a name. I'll name it Cross-Account Access to S3 Bucket, and go ahead and create the policy. Great. Now I have an IAM policy. To use that policy, I need to associate it with an IAM principal, such as a role, user, or group. With the cross-account access objective in mind, I'll create an IAM role and attach the policy to that. After choosing Create Role, I need to specify the trusted entity. In this case, it's another AWS account. I need to know the account ID of the other account, which we'll call the developer account. It just so happens that I'm already logged into that account. I'll copy the account ID and then paste it back here in the IAM role settings. Next, I'll attach the policy I just created. I can search for that policy. it was called cross-account access to S3 bucket. There it is. I don't need to add a tag, but I do need to give this role a name. I'm going to call it access to S3 bucket from dev account and then create it. All right, great. I'm making progress. I'm going to copy the new role's ARN because I'll need to use it in just a moment. So far, everything I've configured has been in the production account. The production account trusts the development account to have access to a particular S3 bucket that exists in the production account. I did this by creating an IAM policy and attaching that to an IAM role in the production account. The role identifies the development account as a trusted principal. In the IAM policy, I also defined the action that users who switch to the role will be able to use. Okay, now I'm logged in to the developer account. Up to this point, I have not used this account in the demo other than to copy the account ID earlier. This development account has a user named AWS student who will try to access the S3 bucket that I created in the production account. So what do I need to configure in this account? First, I need to create an IAM policy to allow the user to assume the role that I already defined in the other account. I'm going to use an inline policy, which means that it's added directly to the IAM user resource. I'll paste the JSON policy in here. This policy has an allow statement that allows the user to assume an IAM role. STS stands for the AWS Security Token Service, also called AWS STS. With this service, you can request temporary, limited privilege credentials. Notice that the resource in this policy is the IAM role that I defined in the production AWS account. I need to replace prod-account-id with the actual account ID. So I'll go back to the browser where I'm logged into the production account and copy that account ID. Now I'm back in the development account and I'll paste the account ID into the policy details. I'm going to name the policy access to S3 bucket in prod account and create it. Now, I want to look at the security credentials tab. Notice the console sign-in link. I'll copy the URL so that I can test it. And I'll enter AWS student as the username and enter the password as well. Now I'm logged in as the AWS student user and I can see that at the top of the screen. Next, I'll open the Amazon S3 console. Notice that there are no buckets. This is expected. That's because the AWS user is logged in to the development account. Remember, the S3 bucket that I want this user to be able to access exists in the production account. To see the bucket, I need to assume the role that I created earlier in the production account. I choose the drop-down menu in the top right of the screen that shows who I'm logged in as, and select Switch Roles. In the next page, I select Switch Role. I'll go to the production account to copy the account number, and then come back to this page and paste it in. The role name was Access to S3 Bucket from Dev Account, so I'll fill that in as well. The display name is optional, but I'll set it to Dev Account User. Finally, I'll choose Switch Role. So now I've assumed the role. Notice the red label at the top of the console shows the account I'm now connected to. I can see the bucket that exists in the production account. I'm logged into the development account, but I can access a resource from the production account because I've temporarily assumed a role that allows the access. Let's see if I can access the image file in that bucket. Yes, I'm able to open it and download it. Returning to the bucket list, notice the bucket in prod account no access bucket. The access column shows error. If I try to view the contents of this bucket, I see an insufficient permissions to list objects error. This is expected because of the permissions I granted in the IAM policy that's attached to the IAM role that I've assumed. Okay, I'm the AWS student user, and I'm finished accessing the S3 bucket in the production account. I want to resume my regular access to resources in the development account. I choose the drop-down menu here and choose Back to AWS Student. The account number displayed at the top is now again the development account number. And when I go to look at the buckets, no buckets display. That is because there are no buckets defined in the development account. In summary, you have seen how to grant permissions to access resources created in one AWS account to a user in another account. You have also seen how a user in another account is able to switch roles and gain access to those resources. Thanks for watching this demonstration. Welcome. In this video, I'll show you how to configure limited access to an AWS account using the AWS Identity and Access Management, or IAM, service. This diagram shows what I will accomplish in this demonstration. A few cafe employees need access to one of the cafe's AWS accounts to perform their roles. One of those users is Nikhil. He needs access to the account to perform the role of an application developer. Meanwhile, Sophia, the account administrator, wants to follow the security best practice of granting least privilege to users. That is, she wants to grant Nikhil only the permissions he needs to perform his tasks. In this demonstration, I'll play the role of Sophia and act as the account administrator. I'll first create an IAM group. Then I'll attach the needed IAM policies to the group. And third, I'll create an IAM user for Nikhil and make him a member of the group. Finally, I'll test logging in as the Nikhil user to verify the account access is what I intended. Okay, let's get started. I'm logged into the AWS Management Console as voclabs/user. You can see this in the menu bar in the upper right corner of the console. For this demonstration, I'll pretend that this voclabs user is Sophia from the cafe. She has full administrative access in the account, so she can create and configure IAM resources. So first I'll navigate to the IAM console. Next, I'll create an IAM group. Other cafe employees or consultants might need access to the cafe's AWS account in the future. By defining a group for this purpose, it will be easier to manage the access granted to these users. It promotes more consistent permissions granting across multiple users as well. I'll name the group App Developers. Next, in the Permissions Policies section, I can search for and attach existing IAM policies to the group. Nikhil and other developers need to be able to see the EC2 instances in the account and do actions like find out the public IP address of an instance so that they can connect to it. However, I don't want to allow them to create new EC2 instances. Given this criteria, I'll grant read-only access to Amazon EC2. Any developers should also be able to access AWS Cloud 9 environments that Sophia creates so that they can code applications collaboratively. Therefore, I'll attach the AWS Cloud 9 Environment Member IAM Managed Policy to this group as well. And I'll go ahead and create this group. There we go. As you can see, the group currently has 0 users in it. Now I'll go to the IAM users area and add a user. The username is Nikhil. For access type, I'll select both programmatic access and AWS Management Console access. Programmatic access means that he can use the access key and secret key to configure his laptop to use the AWS command line interface, known as the AWS CLI, to perform actions for this account. He can also run code that uses the AWS SDKs to interact with this account. Console access means that he can log into the AWS Management Console, like I'm doing now. For console access, I'll create a custom password that I can remember easily. I'll uncheck Require Password Reset, and for the next few screens, I'll accept the default settings. Finally, I'll create the user. Notice this warning that the user has no permissions. That's okay, because in a moment I'll add the user to an IAM group to grant permissions. Normally I would download the access key pair right now by choosing download.csv. In fact, this is the only time that I could do that. However, I will not use the programmatic access in this demonstration, so I'll just skip this download. Great. So I've created the group and I've created the user. Now I need to make Nikhil a member of the app developers group. I'll choose user groups, choose the name of the group, and choose add user and add him to this group. That's done. However, let's see what level of access Nikhil will have from being in this group. Let's look at the Amazon EC2 read-only access policy details. Here you can see that the policy allows EC2 to scribe actions and also allows some read-only actions for Amazon CloudWatch. Why is this? Well, CloudWatch is a monitoring service, and some of the charts and other information in the Amazon EC2 console about the status of EC2 instances are from data that CloudWatch collects. Without these permissions, those areas of the Amazon EC2 console would not display data to users. Okay, so I'm logged into the AWS account as the Voclabs user, who I'm pretending is Sophia. Now I'm going to open a new browser window to log in to the account as Nikhil. I'm going to use an incognito or private browser session. This is convenient for testing purposes because I can stay logged into the console as the Voclabs user in a regular non-incognito browser session. And at the same time, I can use an incognito session to log in to the same account as another user, such as Nikhil. I can switch back and forth between the two user access levels without logging out or logging in repeatedly. The authenticated session information from the incognito browser session remains isolated from the other regular browser session. First, I need to find the URL that Nikhil should use to log in. In the window where I'm logged in as the Voclabs user, Sophia, I go to the Users section and choose Nikhil. On the Security Credentials tab, I find the console sign-in link. I'll copy the URL now, and I'll load that page into the incognito window. Notice that this login page looks different than the root account login page. The page already displays the account ID. For username, I'll enter Nikhil, and I'll type in the password I created. Finally, I'll sign in. Great. Nikhil has now authenticated to the account. You can see that I'm logged in as Nikhil because his name displays in the upper right corner of the console. Next, let's test Nikhil's level of access. Recall that he should have read-only access to Amazon EC2. I'll go ahead and open the Amazon EC2 console. Notice that the region I'm currently in displays in the upper right corner of the screen. I'm currently in the US East 1 region, Northern Virginia. If I was in a different region, I would change to US East 1 because that is where the cafe has some running instances. In the console, Nikhil can see how many instances are running. I'll choose Security Groups in the navigation pane, and you can see that a few exist. Now, I'll try to create a security group. I shouldn't be able to because Nikhil has read-only access in Amazon EC2. Look at that, an error message says that Nikhil is not authorized to perform this operation, just like I expected. Nikhil was granted read-only access to the Amazon EC2 service. He does not have permissions to create Amazon EC2 resources, including security groups. Let's try accessing the Amazon Simple Storage Service, or Amazon S3 console, as Nikhil. I can go to the console, but I can't see anything. That's because Nikhil doesn't have permissions to access Amazon S3 at all, not even read-only access. He can't even list buckets. Nikhil is authenticated to the account, but he is not authorized to interact with the Amazon S3 service. I'll try one more test. I'll go back to the browser window where I'm logged in as Sophia with the Voclabs user. I'll go to the Amazon EC2 console and try to create a new security group called Test. And look at that. As this user, I am authorized to create a security group. In summary, you've seen how to use the console to create an IAM user and grant limited permissions for the AWS account to that user. I could have attached the IAM policies directly to the Nikhil user instead of creating an IAM group, but I did this because attaching policies to a group and then adding users to the group is more scalable. In the future, if